Hi, this is Hani again, and we're looking at my binary search tree implementation in Ruby. And in my previous video about it, we saw how sometimes we have crowding. Like for example, node number 45 in here needs to be on top of 39, and the displaying of the tree causes it to get shifted, and then it gets confusing which node is the parent of which node, so we need to fix this. Also, there is another edge condition, and I'm going to show you that edge condition. It's basically when we have the tree massively asymmetric and it starts overflowing to the left edge of the terminal of the screen in here. So 2 was supposed to be a little bit to the left in here and it couldn't. Same thing with 1, same thing with 0. So let's go ahead and take care of those edge condition. So I have the code. Let's do this one because this one is very obvious and very easy. So what we want to do is we want to detect when a node or a subtree is about to have a negative value for its x-axis. If that happens, we stop the whole displaying of the tree and we do an in-order traverse of every element of the tree and say, hey, shift yourself to the right. And in Ruby it's beautiful because we pass a block. As we're doing in-order traverse, we are passing a block, and in the block, that's when we say, go ahead and shift to the right. So let's go ahead and enable the fix. Where is it? Okay, here it is. So I have the two, I'm adjusting the tree indentation, but the one that concerns us for now is this one. We want to adjust the indentation of the tree in here, so I'm going to click on it. We want to adjust the indentation of the tree to avoid the left screen edge. That makes sense. So let's go ahead and run the code again. And you can see just before displaying the node with 2, 1, or 0, the tree got shifted to the right. So you can see it happening in real time. And here I'm scrolling back up. So 3 was fine, and then we have a left edge overflow. So what did we do? We finished moving the whole tree to the right by 1 indentation. Okay. Same thing. We have again another overflow, and then we did the same, and then third overflow. So this is how we fixed this edge condition. Let's go back to the other edge condition. So I'm going to enable that array that caused the edge condition. Let's run it again so we can see it. Okay, so we have the overcrowding in here. And as I said, node 45 is supposed to be on top of 39, and we don't want that. So the solution in here is a little bit more complex, but it's doable. Nevertheless, 45 happens to be the bigger one, so it'll always be on the right. This is a binary search tree after all. So what we want to do is we want to tell 45 that all your ancestors, we're going to traverse the ancestry tree, and again we're dealing with Ruby. We're passing a block to the traverse method, so we're doing an ancestor traverse and saying, hey everybody, move 1 indentation to the right. We also have to do a descendant traverse. 45 can have descendant here. It can have children here, so we want to move its descendants also to the right. And we also want to go to the parent of 45, and its right descendants, we also want to move them to the right. So that's the fix we have. So let's go ahead and enable the fix. Let's run the code again. Beautiful. you can see how 45 got moved, and then all its ancestors. So we did an ancestor traverse, and the parent, the right child of its parent, we did a descendant traverse. And that's how we did it. And you can see how we added these dashes to kind of signify that the tree has moved to the right. So for now, that's all what I wanted to show you.